In the last talk, we stepped backwards. In this one, we're going to look into death and do autopsies on our code. Whoa. Like, I'm glad that Sam at least laughs at my jokes.
Oh.
No, it's true, not all of them. Sometimes he mocks me for my jokes. You know, Jeff? I can stall more with dumb puns.
Hold on, let's check if... All right, we're good, cool. Let me just restart my timer here. All right, I will soapbox for just a second and say I think it's really, really cool that we've seen multiple talks about debugging, and like previous speaker said, we, at least in the HCI community, don't have a whole lot of evidence about like what sort of debugging tools are useful or not. So I'm here to tell you about another debugging tool that I've developed that has not been evaluated in the HCI manner, at least not yet. So for those of you that don't know me, hi, I'm Jeff. I'm a PhD student at Penn, and today I'm excited to tell you about data-oriented debugging, which is a new approach for thinking about the debugging process and about debugging tools, and about autopsy, a new debugger that implements some of these ideas. And stop me if you heard this before, but today we'll be talking about traces and stepping and other things. So why do I care about debugging? Just to introduce where I'm coming from here, I used to be a senior software engineer, where I worked on auth and notifications and client and server sync, and just all things that are procedural, highly stateful, highly complex, prone to bugs, and really annoying to debug. And in all of that time, I was a habitual print line debugger. But even so, I found that the tools that I had at my disposal were really unsatisfying. So let me start with an example to illustrate what I think are some issues with current debuggers. Let's say you're working on some online retail payment processing pipeline. It does some conventional things that retailers do, like giving discounts on bulk orders and free shipping on orders that are above a certain cost. You've maybe already spotted the bug. Sometimes a customer will get a discount for buying enough items, and then that'll take away what was previously going to be their free shipping, which is a bad experience. This is a toy example, but it represents a pretty common issue, which is that the logic looks reasonable locally, but it produces unreasonable results when you compose it. We're going to, whoops, that was the wrong direction. Okay, we're going to analyze how a programmer might use different debuggers to understand this problem. But first, I need to introduce this visualization that I call the state time chart. We'll use it to understand how different debuggers try to help you debug your code. On the vertical axis, we have all state across all scopes of the program. In our toy example, this is all of the fields of item and also the cart. Imagine that these are sort of distributed across the vertical axis. The horizontal axis represents time. Really, it's like discretized by the program counter, but whatever. And so as each statement of the program executes, computation happens. Take item price, for example, here. Every time we process that line, we compute a new price. And so for a certain row across this chart, a certain value is taking on different values over time. Okay, that is the state time chart. Let's use it to understand how a debugger works. Breakpoint debugging pauses execution at a particular point in time. When paused, you have access to the full complement of all state across the entire program, which is shown in the variables panel in the bottom right. When I press continue, execution runs until it hits the breakpoint again, and I can see all state everywhere at this new moment. This can be great. It leaves me flexible and doesn't require me to predict in advance what state will be relevant to my debugging. And as I continue to use my breakpoint debugger, I'm proceeding through a sequence of stack traces, each of which is a complete vertical slice of state, but at a different point in time. So I like that I can see all of the state and know that it's all related because it's one cohesive picture at a particular moment in time. But if I want to sort of make comparisons across time, I have to keep track of the history and how I got to this point in my head. And I have to decide when to pause and when to inspect things, and also what to inspect. Okay, now let's examine print debugging. When I add a print statement to my code, when execution runs over the print statement, I get a log entry in my terminal, shown in the bottom right, that shows me the values of some variables that I choose at that moment in time. And as the entire program executes, I get a bunch of logs in my terminal, each corresponding to a particular value, taken on by a specific part of the program state. Each of these dots represents a particular log entry. They're arranged horizontally because they all represent state pulled from the same part of the space. Now, if I add a second print line, as the program executes, I get logs whenever one of these print statements executes. And when the whole program executes, I get logs from both print statements, extracting different states from different times. Programmers often insert multiple print statements precisely because, in contrast to breakpoints, it helps them understand sequences of events. But recall the blue bars from the breakpoint debugger. You no longer have access to arbitrary state. You no longer have access to complete information about each moment in time. And also, where I put my print statements and how the program actually executes actually affects the view that I get in my terminal. And so I don't have these like two neat lines of separated logs. Instead, I have this interleaved thing. And the interleaved thing can be helpful when my goal is to understand the history of execution, but it makes it hard to understand the execution in any other way besides chronologically. Okay, we conducted interviews with 12 experienced industry software engineers to understand their debugging practices and why they preferred certain tools and techniques. One major theme that emerged was that their debugging strategies often involved this like active negotiation with collecting and viewing information about their execution. Sometimes they worried about collecting too much stuff. One participant told us that too much unnecessary information could cause them to miss the thing that would tell them where the bug was. Another participant said that a poorly placed breakpoint would disrupt their workflow because it was being triggered all the time. On the other hand, they also worried about not having enough information. They felt this more acutely the longer that it took to get new debugging data. This negotiation process puts these two instincts in tension. On the one hand, I'm inclined to collect more information because maybe it'll help me make sense of the problem. But on the other hand, I worry that if I collect too much, I won't be able to even understand what I'm looking at. Needing to navigate this tension seems to me like incidental complexity of current debuggers, not an inherent part of debugging. I'm a databases person. When I hear this tension, my instinct is that I should be allowed to collect everything, and then I should have rich enough tools that I can manage that large data set that I collect. But so where's this tension coming from in current debuggers? Well, the design of both of the debugging tools that I just talked about couples collection and analysis. There's nothing you can do with print debugging beyond just browsing it and performing text search on it. And your print statements fix the output, forcing you to see only what you've logged, but also forcing you to see everything that you've logged. On the other hand, interactive debugging with a breakpoint debugger is almost the opposite. It forces you to continually make decisions about what data to collect next. You're constantly switching between deciding where do I want to go next, and then looking at the state and deciding, does this make sense? And then on the analysis side, neither has affordances to aid your reasoning beyond just showing you the data. I'll get back to that in a minute. First, let's examine what better collection could look like. So we saw that breakpoints let you see all of the state at one particular moment in time. And print statements let you see particular pieces of state across many moments in time and in order. Well, from a pure data collection perspective, it sure would be nice to just get all that state at all the moments in time. And this is precisely what we designed Autopsy to do. The first part of Autopsy is a Python debugging library. The way that you use it to instrument code looks a lot like print debugging. You just import log from Autopsy, and then you sprinkle these log calls anywhere that you would normally think to instrument your code. The extra interesting bit is that every time one of these log statements triggers, it captures a full stack trace, not just the expressions that you pass in. Here, a full stack trace means every stack frame and the local variables in every stack frame. This is all the information that you would get when you were paused at a breakpoint. And so, one view of the Autopsy interface is like your chronological print statement output, except that you can click on any log entry and see the full stack trace for that moment in time, just like you would see it if you were paused on a breakpoint. It gives you all the data that you asked for, and then more on demand. Next, on to analysis affordances. This project was partially born from me looking at the JavaScript console and sort of looking at how I have these different rows separated by lines and thinking to myself, isn't that a table? Shouldn't I be able to do more stuff with this table of data that I've collected? Which is when I started to think about my debugging logs as a data set in themselves, where I'd previously been thinking of them as the end point of my debugging, where tooling could no longer help it. So to start, we briefly hit upon this ordering problem of only being able to see logs chronologically. One obvious affordance is letting you isolate the logs from different places in your code. By default, autopsy shows you this chronological view, but if you switch to the streams view, they're separated by statement, letting you see all of the logs produced at a particular point in your code. And since all these logs have the same set of arguments, they're presented in a table view, which has some nice properties that we're about to see. So autopsy can replace print debugging and goes beyond it, but what about breakpoint debugging? I want to show you that traces sort of subsume all of the other types of debugging. We tried to give it a similar treatment for first-step debugging. You should be able to follow along with the order that things were captured in. So at each point, we can show you the same information that the breakpoint debugger would have shown you because we're capturing the full stack trace. And since this is all about post-hoc analysis of captured logs, we can do the omniscient debugging thing of letting you step forwards and backwards and jump to arbitrary points in the log. And in fact, the jumping is nice because it's related to your actual logs, so you have sort of semantic hooks into your breakpoints. So here, next to any log in autopsy, I can click this Show in Code button, which gives me a code lens above the corresponding log statement in the code. Then I can click on these buttons to step forward and backwards through the logs. And if I have multiple log statements, the view jumps around to them. It does the breakpoint debugging thing. And since, like I said, since I have full stack trace, I can go and click on any one of these logs, and I can see the full call stack like I would if I were stopped upon a breakpoint. The one glaring difference that you've probably noticed is that this doesn't give me the same experience as breakpoints because it only steps between where I have log statements. We'll get back to that at the end. Okay, well now that I've captured all this extra context at every log line, it seems like I could do more with it. To help with the problem of not having logged the right things, we can now decide that you want to see this other state alongside what you're already seeing. To do so, you just reach inside of the stack trace for a particular log and pull out a relevant bit of state. And then your tools should just propagate that across every log that you have. So here's me doing that in autopsy. When I'm looking at this table, I can open the call stack and pull out relevant state to create new columns. I can also compute arbitrary Python expressions over the captured call stacks and project them into new columns, like total being quantity times price. And just like that, I can enrich my logs with new information on demand. Last affordance that I'll talk about today, ways of getting overviews of the logs and customizing your view. To make certain comparisons easier, or to narrow my focus to an interesting subset of the data, I should be able to say that I only care about logs with a particular characteristic. So I should be able to select only the stuff that I care about, and then throw all the other stuff away and say, change my view to only view those logs. So in autopsy, next to every column header is a filter icon. I can see distributions of values for that variable, letting me easily understand properties of the captured data in aggregate. Is this the right distribution of values for this variable? Are there values in here that I don't expect? And then I can go and say, oh, I only care about when free shipping was true. And this also cross-filters my chronological view. Okay, up next for this project, as soon as I get back from PLATEAU, like literally tomorrow afternoon, I'm running a user study on this. We'd also like to work on efficient trace capture and capture all statements everywhere automatically. I've only covered the most basic queries. I think you could do much, much more with the data that we capture. Being able to make a code change and then diff the traces seems like it could be really powerful. And lastly, I think that there's some story here of like letting coding agents query the data set, either for their own inner agentic coding loop or for creating explanations for humans to help you understand your code. So that's data-oriented debugging and autopsy. For the discussion, happy to hear any comments or questions on any of this, but I'd like to emphasize the first question especially. I'm running a study starting tomorrow, so if there are any questions you think I should be asking participants, please let me know. Thank you so much for your attention. Take any questions you all have, or comments.
maybe this is not a good question, but I'll let you tell me. We're looking at this, we're like, this is so obviously how it should be. And we thought that so strongly that we were like, does something like this not exist? So, like, what's the nearest point of design?
So I heard that IntelliTrace is a thing that exists. I went looking into this last night and found out that it only exists for Enterprise Edition, full-fat Visual Studio, for C# and C++. Why does it exist for other languages, other IDEs? Honestly, I don't know. I think maybe just because nobody has taken this sort of analysis on debugging tools before. I'm not sure. Like I said, there's like sort of a dearth of works on debugging in HCI, so. But it's possible that somebody in the software engineering community invented this in like the 90s. I'm sure. Yeah.
Just sort of follow up for that. I don't know if you've run into like FlowStorm in the Clojure community.
Not familiar with that.
These are sort of like omniscient debuggers. It just traces the evaluation of every expression and then gives you this kind of bird's eye view where you can search through the trace in different ways and things like that.
Yeah.
So yeah, I guess I'm just curious. Like, is this? Are there particular aspects of the interaction or that you're innovating on with this work?
Yeah, so I really like the comparison to. I'm assuming that this is like RR or any other omniscient debugger, but stop me if it's very different. But the thing about omniscient debuggers is that they only do this like one point in time in the interface at a time. Omniscient debuggers largely don't do this, like capture a full program trace. The part at the end is where I think they differ. The ability to do aggregations over like all of the stuff that happened in my program and not just filtering down to a particular point in time.
Or well, I'm not sure if I entirely got it, but I think the starting point of an omniscient debugger is that it traces everything over time. And then there's a question of what interface it presents to the user. Is it just taking that whole trace and giving you this little keyhole moments in time view, or is it giving you some kind of cross-section over time? Is that what you're...
I think so. So like an omniscient debugger, for example, would have a hard time telling me, here's the full set of values that this particular variable takes on across all of the execution, right? It can tell me, it can let me like do the stepping and then I can like see all of them, but it can't show me all of them at once. And I think it's the seeing all of them at once that is the important part.
Very cool work. I was wondering whether you have considered to understanding the amount of time that you spend on each bug when they trying to debug the code, right? So for instance, you have this timeline on the axis, which, you know, if it's pretty wide, probably indicates something like the user spent a lot of thinking, a lot of iterations, which can say about, you know, the struggles, the real struggles, as opposed to, oh, I had a typo. Right?
Yeah, I think it's tricky because I think like 90% of all bugs that you encounter are like, oh, there's an exception here, or oh, there's a typo here. I fix it, it goes away in less than a minute, right? And so this tool probably won't help you with that. What I built this tool to help you with is that the like 1% of cases where you're like, I'm in hell, everything is terrible, I can't understand what's going on. That's sort of when I think like seeing patterns across time or like being unopinionated about what you want to see and being able to just poke around and see like what do things look like here, that's where I think it's helpful.
Yeah, because then you can follow up by saying, well, if I know which bug that users are actually struggling, you can prioritize those bugs and ask them to spend more time as opposed to this needs to be fixed. Right? Again, back to the point you took paper that we're done this year at Kai, it was to annotate the cumulative effort that he's had when they write code. So not just debugging, but actually how much time they spend on every single semantic term.
Gotcha.
That
Okay.
indicates like which part they're struggling, which part they aren't.
Yeah. Okay. That does sound helpful. I'd love to see it.
Let's take one last question.
Sure.
I know that, thanks for the talk, it was really interesting. I know that like in big enterprises, they have like a ton of servers running a bit all around and they get traces from these servers and have this kind of system where you can look into the logs and try to debug like distributed system and these kind of things. I was wondering if you looked into that or how their interfaces work or this kind of thing.
So this alludes to, this is why we care about efficient trace capture. It's why this is a library instead of an IDE extension.
Yeah.
I think there's some potential there. It would be a pretty tough sell for somebody to include this in like their production code. If we could get there, I think that would be so fantastic. So it's an ambition that I have, definitely.
Yeah, maybe it could be enabled when they
Yeah,
are
yeah, exactly.
actually-
We're thinking about some stuff like that, yeah.
Yeah.
Cool, thanks.